first problem here.
Okay, I'm ready.
All right. So when you have parentheses like you have here, the only reason you need parentheses, there's two possibilities. Let's say you had a number in front, or you have a negative in front. Do you see a number in front of either parentheses or a negative in front of either parentheses?
No.
No, so you can drop the parentheses. Okay. So once you drop the parentheses, and you can rewrite it here, you're combining like terms. Do you know what I mean by a like term?
Yeah.
Okay, so like what would go with the 3x squared?
4x squared.
Okay. And what does that become?
7x squared.
Good. And then you do the same thing for the other ones. The operator always goes with it. So in this case, it's positive 6x minus 8x. What does that become?
Negative 2x.
Negative 2x. Good. Really good. All right. Now 9 is the more likely problem that you will have on a test or quiz, because there is subtraction in between the two of them. So this subtraction, it gets distributed to every single thing on the right. You can think of it as changing the signs. Okay, so here's what I mean by that. It becomes minus 8, because 8 was positive, plus x, because minus x was negative, minus x to the 4th.
Okay.
Is that okay?
Yeah.
All right, now I'm just bringing the other one down. Why can I just bring it down? What is not holding it?
Um,
Like we had a negative here. Do you see a negative there?
no.
How about a number on the outside?
No.
Nope. So we can just drop it. Now, combine like terms, okay? And you really want to start with the highest degree power. What happens to those?
They cancel out.
They cancel out. Do you have anything to go with the 7x cubed? Do you see any other x cubes?
No.
Okay, so that just comes down.
Yeah.
7x cubed. How about anything to go with the x there on the right?
No.
Okay. And then what about the 3 and the other number there? What can you do with those?
Add them.
Okay, what do they add up to?
Negative 5.
Good, good. All right, now I did kind of omit some other things here. It says to identify the degree of the polynomial. So we'll do that for this one. The degree is 3. The reason it's 3 is it's the highest exponent.
Okay.
So if we go back to the previous problem, I don't know if you have that there. What would be the degree of this one here on previous?
2.
Power of 2. And then the classify the polynomial by the number of terms. So this has 3 terms. This one we're doing here, that's called a trinomial. Okay, if it has 2 terms, it's called a binomial. You can think of a bicycle or maybe a tricycle to that. And if it has 1 term, it's called a monomial.
Okay.
So if we go back to the previous problem, it has two terms, so it is a binomial.
Do I have to write that in as the answer?
It does say that, but it's more for you to kind of digest and say, okay, like I want you to remember this down here because it sounds like you're going to get a question on the test or the quiz that's asking you to like identify, is it a binomial, trinomial, monomial, something like that.
Okay.
All right, ready to move on to number
Yeah.
10. Find the product. All right, so this really should say to FOIL. You remember FOIL from earlier in the school year?
No.
So FOIL means to take the first, multiply it by the first. C times C. Do you remember what that becomes?
C squared.
C squared. And then O stands for outside, C times minus 3. C times minus 3. That becomes minus 3C. I stands for the inner, so it's minus 5 and C. Minus 5 times C, so that becomes minus 5C. And then L stands for the last. It's minus 5 times minus 3, which is 15. All right, now, can you combine any terms here?
Yeah. Those ones.
Yep. So what does this become? C squared
Minus 8C.
plus
15.
15. Yeah. All right. So we should do another foil here. I know you got a bunch there on your page, but really we should like practice this. I mean, you did a good job, but do you feel like you've never seen this before? Or do you feel like, oh yeah, I've seen it, I just need some review?
Yeah, we did this, but we didn't do like foil. We did like a thing with a square.
Okay. Well, I'm open to however you want to do it. I mean, it's too late in the year for like me to say, hey, you should do it this way. But could you multiply this? I mean, I just want to know that you can do it without assistance. I don't,
Yeah.
if you want to use a square, please do, or we can do the foil method.
All right. B squared minus 2B minus 8.
Good. Okay, excellent. All right. I'm satisfied. You did that very fast as well. All right, so sometimes you'll see me do it a different way, but you are always welcome to use the way that you find most appealing. So since you did so well on that one, why don't you try number 11 here and let me know what you come up with, please.
Okay. 14a squared plus 41a minus 28.
Very good. Okay, I'm really satisfied. That's good. You can do 12 another time. Let's move to 13, 14, and 15. I want to make sure you get good coverage on these. So 14, 15, 13, 14, and 15 are kind of going the other direction. It's basically undoing the FOIL, undoing the multiplication by the square. Okay. Do you remember anything about how to do these types of problems when there is a 1 in front of x squared like there is here?
Oh, because the one's invisible, so it doesn't count. You can just
Doesn't
take,
contribute, that's right.
so you just split it up into two x's.
That's right. It's going to be x and x, but the numbers that go in the binomial here are based on 10 and 7. Do you remember the rule here? I'm going to write it out here. They have to multiply to 10, but add to 7.
Yeah.
So you have
Um,
to think of any two numbers that can multiply to 10.
um,
So for example, like 1 and
uh,
10,
oh yeah,
2 and 5,
two
right?
and five.
2 and 5. So this becomes x plus 2, x plus 5. Does that look unfamiliar to you, or?
No, that makes sense.
Okay, let me have you try another one here. Let me have you try x squared plus 8x plus 15. Like you to do the same thing for this one to factor it, please.
Okay. Um, x plus 5 and x plus 3.
Good. Okay. All right, great. Now let's go to 14. We unfortunately don't have time for me to like show you every single type of factoring. Uh, if we were working together the entire school year, I would definitely have shown you all of these kind of, in various weeks, but can't do that. But the very first type of factoring you should always do is what's called GCF.
Wait, once
GCF,
again, you got a piece of paper.
sure.
Back.
All right. So the first type of factoring that you always do is what's called a GCF, or greatest common factor. I hope you have heard that. Um, it can be as simple as what it is in this problem, which is a -1. Every single one of these can be divided by -1. And you might ask why you would do that, which you can tell me if you do or not, but you just don't want a negative out in front.
Okay.
So this becomes, and the way I'm showing it here is whatever the GCF is, you can divide each of these by the GCF. So it becomes n squared minus n minus 20, like that. Does this at all look familiar?
Not really.
Okay. Well, just go with it for the moment. Um, we'll do a couple more examples here, see if it makes more sense. All right, now the main thing here is that you recognize that it's a equals 1 type problem. So it will be n and n here. This time though, you've got some issues with signs. You're trying to find two numbers that multiply to -20, which is important, but then they add to -1. -1 because of this -1 in front of the n there.
Okay.
Okay, so this is where it's a little bit harder. Can you think of two numbers that multiply to -20? Take anything at this point.
-1 and 20.
-1 and 20, good choice. Start from the beginning. These obviously do not add to -1. You can switch the signs though, but it also does not work. So this is making this list is the hardest thing for most students. It's like they just don't remember or don't take the time to go through the list. But there generally is always something that does work.
Oh, is it negative 5 and 4?
N plus 4, n minus 5, bring down the -1. The order does not matter. Like if you really want to go n minus 5, then n plus 4, that is okay for me.
Okay.
Doesn't matter. Okay, now let's have you try another one of these types of factoring to see if it's clear here. We'll make it too difficult. Let's go w squared minus 6w minus 18. Nope, sorry, that's not going to work. Sorry, let's go to minus 27. So two numbers that multiply to minus 27, but add to -6.
Mm. -3 and 9.
Okay, that definitely works for multiplying to -27, but does that add to -6?
Yeah.
It adds to +6,
Uh.
which means that you just have to switch the signs.
Mm.
So if you get the wrong sign, you know, or it's positive instead of negative, or vice versa, you just switch the signs on the numbers.
Okay.
So this becomes w minus 9, w plus 3.
Okay.
All right, so we're going to look at 15. 15 will give you another chance to practice this, but we're going to get back on track here. I know you probably want to get through a bunch of these, so let's take a look at 15 here. And the very first type of factoring that you're always supposed to do is GCF. GCF, GCF, GCF. It will make your life easier. It will make problems easier if you remember to do this.
Okay.
All right. So we have a GCF of 1/2. And this one's a little bit harder. You're dividing each of these by 1/2. And if you haven't done this in a while, sometimes dividing by a fraction is really awkward. It's fine when it's the same, like 1/2 divided by 1/2 is just 1, it's just x squared. But 4 divided by 1/2, maybe you need a refresher on that. Not sure. What do you think?
2.
So it's like multiplying by the reciprocal. So 4 is really 4 over 1. And then when you multiply by the reciprocal here of the bottom, 2/1, 2/1, do you see how on the bottom everything cancels? But
Yeah.
on the top you get 8. So what you did, the result you just told me is like dividing by 2, you're dividing by 1/2. So it's a little bit different.
Okay.
So minus 8x, that's there. What is 6 divided by 1/2?
12.
12, good. Okay. Okay, so now you're looking for two numbers that multiply to 12. Let me go ahead and reframe this here. Multiply to 12. Okay, but they add to -8.
-2 and -6.
You got it. X minus 2, X minus 6. And then you bring down the 1/2.
Okay.
All right. Any other questions on that before we move on to some other problems here?
No.
Okay. So we're going to look at 17 first, because 17 and the next grouping of problems, it's most like what you've been doing just now. Okay. You want to factor the left-hand side of the equation. You want to do what we've been doing here, x squared minus 8x plus 7. You're trying to find two numbers that multiply to 7, but then add to -8.
Okay. -1 and -7.
Okay, so x minus 1, x minus 7 equals 0, like that. Okay, so in the previous problem, we would be done. We would say, okay, we're done. But here you have to set each factor equal to 0. You have to write equal 0 with both factors.
Okay.
So what would x equal in both of these cases?
Uh, um, it equals 1 and 7.
Good, very good. Okay. All right. So the next one to look at here is number 18, which is very different than anything we've done. And hopefully you say you've seen this before. So notice the leading number here is not 1. Do you
Um,
remember how to solve stuff like this?
mm, not really.
There's a couple of options. One is to use factor by grouping.
Yeah.
Another option is to use the quadratic formula. Either of those stand out to you?
A quadratic formula, right? Because that's what we were doing before.
Could be that it's kind of like you have a lot of ways to solve the same problem. Some are better than others, but Some ways are better than others, but okay, let's do quadratic formula here. What's the value of A, B, and C?
3,
-3.
-2, and 4.
Good, good. And I mentioned this last time. There's this part B squared minus 4AC. That's the most commonly most common part that students mess up here. So would you try calculating that for us, please?
The discriminant.
Yes.
Okay. -44.
So we got -2 squared minus 4 times -3 times 4, like that. Does that look right to you?
Yeah.
4, and then these here, it's 16 times the 3 is 48, but then they're both negative, so it becomes plus 48, like that.
Yeah.
This one I got actually as positive 52. Does that seem right? Seem okay now, just looking at the
Yeah.
signs?
Yeah.
All right.
So is that what it was asking for? Is that the answer? Or?
Well, no. This is just, I'm just trying to make sure everything's okay. So this is the discriminant. So that in terms of the quadratic formula, x equals minus b plus or minus the square root b squared minus 4ac all over 2a. But I kind of don't like this. I thought this worked out nice. I need to look at this one more time here. 1248. Yeah, I guess not. Okay. Looked like it was going to factor okay, but that's not. So we have all the values that we need for this. We know that b, if we go back and look, b is -2. So this is minus a -2 plus or minus the square root of 52 over 2 times -3.
Okay.
So we're almost there. -2 is 2 plus or minus. We got to deal with the square root of 52 over -6.
Okay.
Do you
mm,
remember how to reduce a root like this?
Oh yeah. um,
So I usually start with 2. 2 is the smallest prime numbers, or prime number, and then if it works, you try it again. So you build this factor tree, and factor tree, you're looking for pairs. So you're looking for two numbers that group up together. In this case, that's 2 square root of what's left over, 13.
Okay.
So that all replaces the square root of 52.
Okay.
But we're still not done. I know this problem probably feels like it's going on forever. Plus, they didn't give you a lot of room on the page there to work with.
Yeah.
But you have to divide each of these by the -6. So it's 2 over -6 plus or minus 2 square root of 13 over -6. So on the left, it becomes -1/3. The negative here on the bottom, interestingly, it actually groups in with the plus and minus. So you might think, oh, I'll just switch it to minus plus, but you actually just consume it and it still stays plus or minus. Hopefully, that's not too weird.
Yeah.
Give me some feedback here. Is this seem difficult? Is this weird? Like, give me kind of tell me what you're thinking.
Yeah, it's pretty confusing.
I agree. I agree. This one wasn't the kind of when you get these reviews, sometimes they're not in an order where it's helpful for learning, especially if you feel like you were already struggling to see it.
Yeah,
So,
I got like they told us to do it in like certain groups of problems.
okay.
I have another paper that tells me those, but yeah.
All right. Well, let's look at number 14. It's actually kind of similar to what we just did.
Oh, we already did 14. We
I'm
did.
sorry, 16. 16.
Okay.
I misread the numbers. All right, so this is a little bit different than the last ones. It's not quadratic formula.
Yeah.
It's it's solving for x squared. So you can divide both sides by -3. So x squared equals 27. I'm sorry. Wow, that's really bad. That's 18. 18.
Uh-huh.
So to solve this, you take the square root of both sides. And now, kind of like the last problem, you have to reduce the square root of 18.
Okay.
And I would again say, okay, start with 2. 2 times 9. 2 does not go into 9, but 3 does. 3 and 3. And so you're looking for pairs. There's a pair of 3s. That means the 3 is going to come out, but this 2 is going to stay in. So it becomes 3 square root of 2.
Okay.
And this is where maybe I need some more feedback to say, like, hey, Matthew, like, let's do another one like this one, or, hey, let's move to something else completely. What would help you the most right now?
I don't know. I guess is that the answer though, or
Yeah, this is the solution.
okay.
I think we should do another one like this.
But
And then
can we do 12 real quick and then go on to that?
sure,
Yeah.
sure. So 12, I had suggested that um, you foil this, which you said you're doing the square method.
Yeah.
So go ahead and try that out.
Okay. So 4x squared minus 1.
Yes, very good. All right. So why don't we just transition to a completely new topic? It looks like there's you don't have to do this in a certain order, do you?
Um, no, yeah, it's just like I'm supposed to do like certain groups of them together, but it doesn't
Okay.
matter what order I do them.
Yeah, it just think maybe sometimes it's good for the brain to kind of reset by doing something just totally different. That way you're not dwelling on stuff that we've been doing. Um, so let me give me 30 seconds. I'll be right back.
Okay.
All right, I'm back. So I thought we would look at starting with 35.
Okay.
35 here. So kind of just transitioning completely. It says to determine whether the sequence is arithmetic, geometric, or neither. So arithmetic means that it has a common difference. Okay, so like when you look at the numbers 2, 4, 6, and 8, do they go up by the same amount each time? Meaning like adding or subtracting.
No.
Okay. I see
Oh,
that they go up by
they
2
do. They
each time.
do. Sorry.
Yes. So this is arithmetic. All right. So that means you just have to say it, and then to support your answer, you can just show that it has a common difference. Maybe just say that as a common difference of 2. Is that okay?
Yeah.
All right. All right. So next problem here is 36. So 5, maybe these aren't that, maybe they aren't that are easy to see. 5 minus 10, 20 minus 40. Are they going up by the same amount? Like if you were to add or subtract the same number, do you get to the next term?
No.
No. Okay. Now for geometric, which is the next one, it's multiplication or division. So like, do you multiply by the same thing to get to the next term?
I assume so. Or do
Okay. I mean, that's reasonable, but like, what would that be? And like, forget about the sign for a moment. Just look at the numbers 5, 10, 20, 40. What are you multiplying by each time to go up?
2.
By 2. Good. Okay. But the problem is that the sign changes. So when you see a sign change, that means it's really negative 2 or negative of the multiplier.
Okay.
All right. I mean, we only got another 8 minutes. Okay. So I mean, the drudgery of this will end here shortly. But let's do a few more problems. Hopefully this is helping.
Yeah.
So let me, no, not that one. All right, I'm gonna have you do 38 here. I want you to tell me if this is a geometric, arithmetic, or neither.
It's geometric.
Okay. What is it going down by? What is the ratio?
2.
So you can't, if you say 2, that's like multiplication by 2. You have to either say multiplication by 2 or multiplication by, for example, 1/2. So yes, you're dividing by 2, but you write this,
Oh, okay.
right? Or better yet, say multiply by 1/2.
Okay.
All right, so let's look at 37 next. So we've got 4, 9, 16, and 25. So if you just start by saying, well, what do you add each time? +5, +7, +9. Notice that this is not the same each time.
Yeah. But doesn't it go up? Don't those numbers go up by two each time? That's what they told us to do.
Okay, well, but it's not geometric. Or, I'm sorry, it's not arithmetic and it's not geometric. This is actually a quadratic series. But keep in mind, you're looking at like what is going on between the numbers. Like, can you multiply by the same thing to go from 4 to 9 as 9 to 16? The answer is no. So this would be a neither.
Okay.
All right. Let's take a look, see what else you've got here. Okay. So for 33 and 34, it's kind of the same situation
Yeah.
as what we've just been doing. You have to determine whether it's going up or down by a constant amount. Like, do you multiply by the same thing each time? In other words, like, what is 8 divided by 2? What is 24 divided by 8? What is 128 divided by 24? And are these the same, right? So 8 divided by 2 is 4. 24 divided by 8 is 3. 128 divided by 24 is something. Doesn't work out nicely. 5 1/3, we'll say. All right, so that one's not looking good. Let's look at 34. That one actually does work out a little bit better.
Mm.
Okay, so it's kind of the same deal here. It's you take 20 divided by 40, then 10 divided by 20, then 5 divided by 10. And are these all the same?
Yeah.
So that means this is exponential. Exponential's a lot like geometric.
So what do I say for 33? If it's not.
Well, we're gonna get back to it. But I just wanted to show you that this one is an exponential model for sure, because these are all the same. You have to decide whether whether it's growing, getting larger or smaller. Bigger or smaller, basically. And you're looking at the y values. Do they get bigger or do they get smaller?
Okay.
What do you
So
say?
the 33 is growing.
They're growing. So growth, that's called a growth model. Okay. Now the problem with 33 is it's not growing by the same amount. It's not, it is getting larger, but not by the same amounts. I'm not sure that this is correct. Like if you had to pin me down for an answer, I would say it's neither, because it's not growing by the same amount each time. But the general graph of this is growth, like it's getting larger each time. So I know that that's not specific enough for what you're looking for, but that's kind of the information I would want to go ask my teacher about. Say, hey, I was working this problem and I noticed that it's getting bigger, but the ratios are different each time, and see what they say.
Okay.
For the next one, it's decay. And we can for sure say that it's decay. It is exponential because the decay is going down by the same amount each time.
Okay.
All right. Well, that's going to do it for us for today, Tenzin. I know it's late and I know that